I'd like to welcome you to this lecture number 6 in a row of 12 plus 1 lectures in introductory statistics. We have 12 lectures with new stuff. This is number 6, so that's a big day today, where we reach the median of our number of lectures with new information. I don't know how you have it, but I like when I meet medians in my life, or quartiles, or whatever kind of neat number that hits us every day, every second of our lives. Wouldn't it be nice to know what they are when you meet them? So that's why you should listen in here. Today we're going to have another breathtaking novelty hitting us. Today we're going to make the big step going from 1 to 2, in some sense. What did we do in the course so far? We studied data on day 1. We spent 2 days on probability. And then we spent 3 days on, if I can count, statistics for a single sample, single column in our data sheet, whatever. What is statistics? That is hypothesis testing and confidence intervals. So now we can do hypothesis testing and confidence intervals when we have a single sample of data. Today, we are going to be able to compare 2 samples of data. And we have a nice long list of things we need to do. I'm gonna put approximately here, that's halfway through. And apart from the 2 sample case that I will motivate even more in a sec, we are going to do another new thing today, which comes as a part of the second hour. We are going to think in terms of planning of experiments. We didn't talk about that yet. Now, I've analyzed you how to analyze the data after the first lecture here, but we need to think about how to plan those studies in the first place. And that is a very important part that we will cover at the end of today. Little motivating example. We brought some small toy data that we can play around with for everyone to follow. This is a kind of study you could have done if you studied nutrition, for instance, at the former Agricultural University of Denmark, now part of Copenhagen University. Nutrition is an important thing studied. What should we eat? How should we eat it? And so on and so forth. Or how much energy do we spend on different kinds of work? For instance, here we have, let us see, nurses from Hospital A and nurses from Hospital B have been compared when it comes to the energy spent in their work. So I would have 9 in each hospital, that is 18 nurses altogether that I have studied. 9 nurses here and 9 nurses here. And the big question is a comparison of the average energy level spent. I want to compare 2 means with each other. I hope that you can have the idea that this about comparing 2 groups with each other is a pretty important thing in looking at numbers. I want to compare my treatment with a control group. I want to compare people living next to windmills with noise with people who don't live next to windmills. I want to compare people, at least some decades ago, one wanted to compare people using cell phones with people not using cell phones. I don't think that comparison would be possible anymore. Still, there were some rather big studies speculating on the long-term health risks potentially, and a bit debate and a lot of disagreement about what those studies really told us or didn't tell us. Still, I'm not quite sure what the results are. We might see in the future what happens to all of us. It's going to be worse for you than for me, because I had an age of around 30 or so before I even knew what a cell phone was. And you guys, you had one in your ear from the beginning, right? Let's hope that those studies telling us that there was a risk were not right. But there are many other risks. Anyway, here is basically what I'm going to teach you when it comes to comparing 2 groups with each other. This is the usual way. I show you how it works in practice, and then we teach you how to do it. The hypothesis for the test is this one. We hypothesize that the 2 mean energy expenditures would be the same in the two populations. Now I have two populations, the sample from each population. I would, of course, when it comes to computational efforts, do what the only thing basically I can do is to compute the mean and the standard deviation. So if we do that again, we just do it twice instead of only once. Compare the two means. Somehow, the means have a difference of 2.005. The question is whether this difference is large enough to make us question the hypothesis of the true mean being 0. And we are going to show you how to find, now you know the idea, a hypothesis test p-value for that hypothesis. In this case, it turns out, what does it show? Is this a small or a large p-value? That's a small p-value. It's below, well, I didn't state the alpha. If no one stated the alpha, probably we use the 5%. That's the global default. And the p-value here is even below 1%. So yes, the p-value is small. Yes, I have pretty clear evidence that these means are different, right? That these two groups of nurses in the different hospitals, they have different levels of energy usage at their work. And what you will also see, you learn a little Danish, nyt equals new, and so on and so forth. It's very easy, it's almost the same. We can also do a confidence interval for the difference between two means. And it looks like this. The formula will be there in 25 minutes. And we can summarize that we believe not only that it's different, we can also quantify the size of the difference. It's on average, our best guess is 2, but somewhere between 0.6 and 3.4, I would say, is the difference, right? That's the confidence interval hypothesis test, two sides of the same thing. That's what we will learn you in the first part today.